Okay, in this video, I will be explaining all about the port scanning. In the last video, I talked about the host discovery, and in this video, I will explaining all about the port scanning, how to do it, what are the different ports, what are the different scan of Nmap. If you have not watched the previous video, I will definitely recommend checking it out first. And in this video, I will be covering these things. First of all, we'll understand what are ports and how they work, the difference between TCP and UDP scan. Second of all, I will talking about different TCP flags like the RST, the URG, ACK, sync packet, and a lot more. And after that, I will talk about two different type of the TCP port scanning. The one is the connect scan and another is the TCP sync scan. Both are very different and both kind of give the same result. So don't worry, I will be explaining both of these in detail. And after that, I will talk about the UDP port scanning. What are the commands for UDP port scanning? What are the different way to figure out if the port is open or closed? So yeah, by the end of this video, you will understand all of these in very detail. And without any further delay, let's get started. Okay, so in the last video, I will talk about the host discovery, like finding out the devices that are live on a specific IP. I will cover it in detail. If you have not watched, I will definitely recommend checking it out. And in this video, what we're gonna talk about is that we will be learning about, let's say, yeah, we find out that yeah, the device is active, the device is alive on that specific IP. Now what are the services that is running on that specific device? That is what we will be finding out in this video. Okay, and it's exactly what we call the port scanning. Through port scanning, we find out what are the services that is running on the machine currently, and what ports are running, and what are closed, and which one are filtered, and as well as we might find out their specific version as well. First of all, if you don't know what is a port, I'm gonna tell you what is a port. First, IP addresses gets you to the right machine, like we figure out in the previous video that what hosts are alive. Now a port gets you to the right service on that machine. There might be, let's say, when you run your computer, when you run or boot up your computer, you open multiple applications like Spotify and the browser and a lot more. So how does it all of these applications at once receive the data? Basically it uses port, and each of the application uses some specific port. So whenever the traffic comes from the internet to your router, the router just send it to the device. It checks the IP of your machine, of your device, and once it's on your sent to your device, it checks the device, check that okay, which specific service is listening on this specific port. If let's say on port 111, I'm just gonna tell you random example. Port 111, there is Spotify listening, it will send the streaming data. If you are also browsing and just watching something, Netflix or something, and it is on a specific port, another port, it will forward it to you as well, because the application is listening on another port. So on different port, different services run, and that's exactly what we're going to be finding out. Every service running on a machine bends to a specific port. That's what I told you. When data arrives at a machine, the operating system looks at the destination port, okay, and the port it will reach to out to, and route the traffic to whatever process is listening on that port. If nothing is listening on that port, the operating system just simply reject the connection. That is what I just told you, the example of Spotify and Netflix browser. And we have total number of ports. We have 65535. These are the total number of port out there exist, and it is basically divided into three ranges. The first range we have is the well-known port, which start from 0 to 1023. These are widely used services. And the next category of ports we have is these are the register port, and register with INA for specific services, but they can be changed as well, not like very rigid, that they cannot be changed, right? And the third one is the dynamic ephemeral ports. These are the ports used by the operating system for outbound connection. Let's say you open your browser and you are visiting to some website or some services. These are the ports that your browser or any other application will use as its source port for the duration of the connection, right? Now let's talk about the TCP flags. TCP packets carries a header. These are a structured block of metadata that tells the receiving side what to do with the packet actually. So in that metadata structure block of metadata, there is a field containing 6 different options, and these 6 different options are the flag that I'm gonna just tell you. And it can be on at a time, or it can be off, and multiple flags can be on at a time. And over here you can see these flags are the heart of port scanning. Different scan types work by sending packets with specific flag combination and observing how the target respond. Okay, now let's talk about the different type of flag. First of all, we have the URG or urgent flag. This used to be in older scans type, like for example the Xmas scan. Honestly, you will see this specific flag rarely these days. Next one we have is the acknowledge ACK acknowledge flag. This ACK flag actually tells the sender side that the specific data has been received, and we are good to go. You can go next and send more data as well. A normal TCP connection, when you want to connect to a service or website, first of all you send the sync packet, and if the service over there is listening, it will send back to you the sync acknowledge packet. So it is kind of acknowledging that, yeah, I have received what you want, and let's just do that. Another type of flag we have is the PSH or push. It means that tells the receiving TCP stack where the data gets stored, that immediately process this data instead of storing it and using it later, like buffering without buffering it, right? This RST or reset packet, when when you receive this, it means the connection has been stopped. It's like saying that the connection has been stopped. In port scanning, when you receive this, it will be probably the port is closed. If the port is closed and nothing is listening there, so you will get the reset packet, and from that the Nmap can report that, yeah, the port specific port is closed. Another one we have is the sync or synchronization flag. It initialize the TCP connection. From this we start the TCP connection. You already know that. And this last type of flag, the fin or finish flag, what it does is it when the data receiving and sending is done from both sides, it basically just stop the connection, not immediately just like the RST packet, because it just immediately stop the connection, and it makes sure the data receiving and sending is done, and after that it closes the connection and both agrees on that, right? So hope you understood these different type of flag. Now let's talk about the TCP connect scan. These we'll be now talking about the different type of Nmap scan. First of all, we have the TCP connect scan, which we specify with the -st. So when you are doing the port scanning and using the specific connect scan, the st with Nmap, what it's gonna do is it will actually create connection, create the full, it will establish the full connection TCP, like it will complete the three handshake. Like you send the sync packet to the specific port, and it will send, if it is listening, it will send you back the acknowledge packet, and you will then send the, yeah, I also acknowledge that. So when you are doing the port scanning, what you're going to do is when you use this connection, what will happen actually is that, let's say you want to figure out if the port area is open or no. So you will send the sync packet to that port on that specific machine, on that target machine, and if the port area is open, it will send back the acknowledge packet, sync acknowledge packet, flag packet, right? And once you receive that, your machine will send that, yeah, I have got your packet, here is, I acknowledge that, yeah. So once you receive the sync acknowledge packet, your machine will then send the another acknowledge packet, and thus the TCP three-way handshake will gets completed, and the connection will get established. And this is and Nmap will report that, yeah, the port, that specific port is open. But if you receive the RST packet instead of the SCK packet from the target machine, it means that the port is closed, right? So when the connection is established, after the data sending and receiving is done, it will then send the TCP RST packet, meaning it will just tell that I'm just gonna stop the connection immediately. And this is for open port. For closed port, what's gonna happen is that you will send the TCP sync packet, and since there is nothing listening, you will not get the acknowledge packet, and this is it will just report, the Nmap will report it out that, yeah, the port is closed. Another, for the firewall, when there is port open but it is filtered with the firewall, what gonna happen is that you will send the sync packet and the firewall will receive your packet and it will just drop your packet silently, and you will be waiting, the Nmap will be waiting for any response. But since the firewall just silently drop the packet, it will not receive, and after some time the Nmap will just say waiting and timeout reach, and it will just kind of report it as filtered. The problem with this specific connection is, as I said, that it completes the three-way handshake, and whatever completes the three-way handshake, it gets logged. So later on, a system administrator reviewing logs can see your scan activity in application level log, that yeah, from this specific source IP addresses to this specific port, the connection, someone tried to connect to that specific port, so they can later check these logs. But in exam, the certification, this does not really matter. And here is the actual command actual structure, how you can start the TCP connect scan. First of all, you'll type the Nmap and then specify the -st, as I told you about that. When you are specifying, when you are doing the connect scan, you will have to specify that, and after that you will specify your target, and later on, if you want to specify specific port, you can also do that. For example, this is the command prompt, and I wanna just do some scan on some website. Okay, so this is the connect scan, and this is the IP of the target, and I'm gonna start doing the TCP connect scan on this target machine, on this target IP. So let's just start this, and let's come back when the report gets complete, the scan gets completed. You will see result like this: the starting time, then report, and basically these are the important stuff over here. These are the services. It says over here that the host is up. Okay, the IPv targeted is hub up, and the out of, since this is a default scan, uh it will just scan the default ports. As told you, that default ports are the around the thousand, first 1,000 ports. From that 1,000 ports, around that 1,000 port, 996 ports are closed, and these ports are only open and listing. So on port 22, it's open and the service is SSH, and on 80 HTTP, and 139 the net BIOS, and 445 the Microsoft DS. Right, these are the service that is listening on the specific port. The scan is still going on. Let's just wait for this. Now this is another way to specify specific ports for the connect scan. The same structure, but you will have to use the -p. With that, you will have to specify the ports, and the rest is the same. And if you want to reduce it, the port count, like instead of the 1,000, you want to just do the first 100 ports. So the same thing, but this -f, capital F, this means fast mode, and it reduces the default ports, 100 ports, to down to the 100 most common ports. Right, so I think instead of the let's use the F as well in this, or it's just already done. So over here you can see that the port 80 is open, port 443 is also open on this. It basically done the three-way handshake, completed the three-way handshake on this port, and it received back. So that is why the Nmap reported that these ports are open. The next scan we have is that TCP sync scan, which is the -SS, and this is the very most important scan. The main difference in this scan is that the above scan that we talk about completes the three-way handshake, and this scan, what it do is it send the sync packet, and if the port is the service is listening, if the port is open over there, it will send the acknowledge packet. Okay, and our device will not send the acknowledge packet to complete the three-way handshake. That's the main difference. In that complete connect scan, it will send the acknowledge packet at last to fully completed the three-way handshake, but this won't do. Or here, this is the example, visual example. TCP scan port to port ID, I want to connect. If the port is open, accept it, and it will send you back this thing SEK and to your device, and it will never send the last flag, the SCK, that yeah, I got your packet and let's just establish the connection. It will, instead of that, it will send the RST packet to just immediately stop the connection without establishing it. It just figure out this one is like a clever scan. Instead of connecting the full, instead of completing the connection three-way handshake, it finds out that yeah, someone is listening. Let's just end this because we already figured out that yeah, somebody is listening. So we'll just, Nmap will just report it out as the port is open. And if the port is closed, you will send the sync packet. Since nothing is listening, you will just simply get the RST packet, and well, Nmap will report it out as closed. And to do this scan, what we're gonna do is you will have to type that nmap hyphen s small s and then capital S and specify the target. And if you want to specify some port, you can do it with the hyphen p. Let's just do that as well, but I'm gonna use the hyphen f so that it will use the default top 100 most common ports. Okay, so for that you will have to the most important thing is that to run this scan, you must be a root user if you are on Linux, or if you are on Windows, you must be a administrative user. You must have admin privileges. So I'm gonna open the PowerShell with admin right now. This one does not have, so it won't do this scan. Over here, nmap and v is the verbose. It will show what it is doing as it goes with the scan, and this is the scan type, and this is hyphen f I have specified so that it can scan the top 100 ports. Let's just wait for this and see what happens. Over here you can see that discover port, this is open on this specific IP. Okay, and it's just doing port AD is also open, and yeah, just both of these ports are open, and the result is very identical to the connects, and that is the most important part. The same result we got in that above scan as well, and this is exactly the same over here. The main thing is that the three-way handshake completion, it completes it and it doesn't, and the one who completes it, it gets log and can be received, can be reviewed by the administrator, system administrator, and this doesn't complete, so it doesn't really make the noise and the logs, right? The next type of scan we have is the UDP scan. Unlike the TCP, it has the three-way handshake. You send the sync packet, it receive this target, receive give you the packet back if it is alive, and you send back, and the connection get established. With UDP, when you send a UDP packet to any port, several things can happen depending on the port state, and whatever result we get will not be as clear cut. We cannot like just say that yeah, the port is open or it is not open or it is filtered. This is the limitation of the UDP port. But what actually happen if the port is open? Over here you can see the, let's say there is a UDP port which is open and it actually responses back. You send a UDP packet to an open port and the service running there generates some traffic and send it back to you. So from that we can specify that yeah, the port is actually open because we just received response back from that specific port. But what if the port is open, but if doesn't really respond? And this actually usually happen. From the port perspective, what happens is that UDP port could be open, but it ignore your scan, but it ignore your packet, or there might be a firewall that just silently drop your packet. Either way, you will just don't get any clear cut result, and Nmap will report it out that open slash filtered. And if the UDP port is closed, it just send you back the ICMP packet specifically type 3, and it will say that the port is unreachable, meaning from that we can specify, from that we can tell that the port is closed. And same is the case for the filter UDP port. It will report it out as open slash filtered. The same case over here, right? Another thing is that when you are getting some exam, you don't have to scan all of the UDP ports because it is slower. The reason it is slower is that for example, when our TCP port is closed, you just immediately get the RST packet like within a millisecond, and Nmap reported out that the port is closed. But with the UDP port, when it is closed, it will wait for the ICMP unreachable packet and move. It will then move into the next port scanning. But there is something called the ICMP rate limiting, and the limit exceeded from there, it will which many systems do over here. You can see to prevent the ICMP flooding, and because of that, the ICMP response arrives slowly, and you might not even get the response. It will just report it out that the port is actually closed even if they are open. The main point I'm speaking about is that you don't have to scan all of these ports. Instead, an exam like this, you don't have to scan all of these TCP UDP port. You can scan a specific UDP port that you might feel like that, yeah, there is something in it. And these are the ports like the DNS, TFTP, NTP, SNMP. SNMP is very interesting. Out of this we'll cover later in some other video, not gonna cover in this video, but yeah, the point is that you don't have to scan all of the UDP port because it is slower, it takes a lot of time. You have to scan the important ones only, and this is how you actually do the UDP scanning. Nmap, again with the administrator right, or admin right, or root, you run the nmap with -su, which enable the UDP scan, and then we are specifying the top ports. From this we can specify top port 10 or 20 or 50, uh, and then the target machine. So I'm just gonna copy this and get back over here and then send paste the target IP. So let's just wait for this, or instead I will use the v as well with it. Let's do this, and let's specify the 50 ports, top 50, and then I will use the v so that it tell me things it has go, show me the report it goes. Let's just wait what we get, and then let's figure it out. Okay, so there is a lot of the ports. You see right here, open/filter. It doesn't tell you really. Over here you can see that the SNMP is open/filter. It is open because it is not closed, but it is either open, drops your packet, doesn't respond back, or it is filter. So these are the important ones that I was just talking about. You can just do it the scanning like this, and if you want to specify some certain ports instead of the top 50, you can just use the p and then specify the port like to like whatever port you want to specify, right? So this is how actually you do the UDP scanning. And next we have, you can combine the UDP and TCP scan simultaneously, but the problem with this is, first of all, this is how you do it. Nmap and use the SS and SU. This just take care of the UDP and this the TCP. So the problem with this is it will work completely well, it will give you the result back, but the problem is it will take a lot of time, not the TCP but the UDP one. So if you want to just get TCP ports, you can just go with the TCP, and if you want UDP you can go UDP, and if you want a detailed comprehensive report scan, you can just do this, and you will have to wait, but it will be both, right? So that's pretty much it. We have talked about the ports, what are ports, and then I talk about the different flags, different TCP flags, and then we talk about the connect scan, then the another scan, the SS scan, and I have talked about the UDP scan and why UDP is slower and which one is important, and then I have talked about the UDP scan, how to do the UDP port scanning. So yeah, if you have any question in any of these, let me know, and in the next video we'll be going a bit more further. This is just basic port scanning, UDP TCP port scanning, basic ones. In the next video we will go a bit more advanced. So I will see you in the next video. See you soon.